Today we're going to talk about the solubility guidelines for aqueous solutions. So before I begin, get up your reference table. Table F. Table F. Okay. Now, what we have here is we have a column, four columns. We have soluble, we have exceptions, we have, whoops, my bad. We have insoluble, and then we have the exceptions. I drew the insoluble ones in red, which means they will not dissolve in water. And I drew the soluble ones in green, which means that they will dissolve in water. So basically, the way that this chart works is I'm going to write down a few different examples, and we're going to figure out where they go. So let's say we had something like lithium hydroxide. So we have LiOH. Now, where does lithium hydroxide fall in this area? We could look at two different things. Let's look at the lithium first before we look at the hydroxide. So when we look at lithium, we got to figure out where it falls on the periodic table. Now, because lithium is in group 1, it is automatically soluble. So anything containing lithium, if you look right here, it says group 1 ions, lithium hydroxide, no matter what it's attached to, is soluble. Let's look at the other half just to show you how this works. So when we look at lithium hydroxide by analyzing the hydroxide first, the OH, we're going to look on our table and look for OH, 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 OH. I don't see any OH in the first column. We're going to look over here in this column. I see an OH. It forms an insoluble compound. However, it becomes soluble when there is an exception to that rule. So it becomes soluble when it's combined with a group 1 ion, like any group 1 ion, lithium, sodium, potassium. And it's also when it's combined with calcium, barium, strontium, or ammonium. So lithium hydroxide would also go here for the hydroxide. It can't be soluble once and insoluble another time. It's going to be both the same. So let's try another example. Not lithium hydroxide. Let's try copper hydroxide. In fact, we're going to try copper 2 hydroxide. So let's look for copper. Copper, 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 copper. Nowhere. Now we got to look back for hydroxide. Hydroxide is right here in the insoluble column. When we look, nothing that's attached to it, the copper, makes it an exception because it's not calcium, barium, strontium, or ammonium. So copper hydroxide would fall in the insoluble area. Let's try another one. Let's try lead chloride. Now we're going to start off by looking in our soluble and the insoluble. We're going to start looking up in the first and the third column. Do I see any lead? As I look through here, I see no lead. As I look through here, I see no lead. However, let's look for the chloride. Since chlorine is in group 17, it's actually called a halide. Another word is a halogen. These are called halogens. So it's either called a halide, it's a compound with a halogen. So anything containing a halide, if you look right here, chlorine is in the halides. So lead chloride would be here. But let's make sure, is there an exception to lead chloride? Chlorine is normally soluble. When it's combined with silver, lead, or mercury, it becomes insoluble. Okay? Let's try one more. We're going to try, let's try calcium phosphate. Calcium phosphate. I'm going to describe the solubility of calcium phosphate. Ca3PO4 2. Calcium phosphate. Now, as I look here, it is not in the soluble. There is no calcium, there is no phosphate. As I look in the insoluble, there is a phosphate. So phosphates are normally insoluble. But let's see if calcium is an exception. So phosphate is here. Is there a calcium on the right column? That would make it an exception. Phosphate, no. There is no calcium. So calcium phosphate is insoluble. Look over here. Try your practice problems. Boom, we done.